Hello, this will be section 2.2 in a Triola Statistics course, and this is about histograms. Basic definition is a histogram is a graph consisting of bars that are equal width, drawn adjacent to each other, and then the horizontal scale represents the classes of the quantitative data values, and the vertical scales represents the frequencies. The heights of the bars correspond to the frequency values. So this is where we take a table from section 2.1 and now create a visual representation of it as a graph. The uses visually displays the shape of the distribution, shows the location of the center of the data, shows the spread of the data, and identifies outliers. So here's our McDonald's. You'll notice these are the classes, these are the frequencies. You'll notice the boundary point, that class boundary, is that middle 124.5 that we talked about in 2.1. There's no gap here. They're touching each other. This goes up to 11. That's the first class, frequency 11, 24, 10, 3, and 2. You can also do this for the relative frequency. So changing these to 11 divided by the 50. Remember adding these all up and getting the percent of 22%. And it's basically the same shape, right? It just shows the only thing that changes is the vertical scale is now your percentage. It's your relative frequency graph. Here's some common distributions you might encounter. We're really interested in this one here. It's the bell-shaped or normal distribution. You'll notice that it's low on the left side and low on the right side. And then it mirrors each other as you go up both sides and shaped like this. It's shaped like a bell. It's this kind of mirrored on the whole thing, and that's kind of called a normal distribution or the bell-shaped curve. Uniform distribution is they're basically all the same size, the bars are, right? They're all the same. A distribution that might be skewed to the right has the tail that has the kind of drifts off to the right. So this one here looks similar to the normal distribution, except it's not symmetric, right? It has starts getting higher faster and then tails off to the right, skewed to the right. This one, it has the tail going to the left. It takes a while to start actually going up, and then it sharply declines, right? So this one's skewed to the left where the tail is. So to be normally distributed, you need to be relatively looking like a bell-shaped curve where it matches things symmetric. Here's where an example of a bell-shaped curve. That curve there is the exact normal distribution. And then we see this green area here with the bars, this histogram, and we say that this is approximately normal, or approximately has a normal distribution. It has that bell-shaped look. It's low here, it's low here. It jumps up, and it kind of gets the height is right in the middle, where it's the tallest. It's not exactly a normal distribution, but it is approximately. Here they say it is roughly bell-shaped. So we say it's a normal distribution. Here's an example. We're going to take some data that we're given, and we're going to create ourselves a histogram in StatCrunch. Now, StatCrunch can only create histograms with pure data. So I'm going to open this data in StatCrunch and then show you how to do that. We're going to start at 40 because these are test scores, and the lowest ones, I have them all ordered. You can see that, right? The lowest is 48, and we're going to go up by 10. This class width is arbitrary, and it's given or picked by the person presenting the data. And it makes sense with a grading scale here that we might go up by 10s. All right, so let's open this up. I have the data opened up in StatCrunch here, and call a variable 1 here. This will be for something later. And we're going to go to graph, histogram. So since we have data, we can open up a histogram. The information we want is in the variable 1 column. And what we're going to do is we have a frequency table. We want to know how many are within a certain range. Now, I said classes. StatCrunch calls it bins. And so we want to start at 40, and then our class width was 10. And then that's all the rest that we need to worry about. And that will create our histogram. Starting at 40, 50, if you put your cursor on it, it tells you how many there are. There's an option that I should have probably clicked. Value above the bar. Click that, and now we'll put the 3 above the bar. So now we can see how many there are. And you notice that it's from 40 to 50, including 40 but not 50. 50 to 60, and so you can see how it's grouping them. So that'd be a histogram of the data. And maybe you want to change the y-axis because you might want to make it a little taller. So I put 25 in there, and now it goes to 25. It's even every 5. Okay. Let's go back to the homework question. So here's a video that kind of does the same thing if you want to see a video, and then here's some data if you want to copy it. So is it normal? Is it skewed left or is it skewed right? Does it fit that normal curve, right? Does it fit this normal curve? Does it look exactly like that, or does it look like one of these two? I think it kind of looks like this one, right? Skewed left a little bit. It's moved over to the right. So it's a little lower here, and then it comes sharply down, right? So it's not quite normal. It would have to be more, have this one up with it to be a normal curve. Now StatCrunch doesn't do a histogram with summarized data. This is summarized. This is a table already created. So I'm going to create a bar chart like this. It's done the same kind of way. You go into StatCrunch. We'll close this one. Here's our information. These are ages and tallies. So I go to graph, but go to bar plot. You can do that with data or with summary, but you can't do histogram. Histogram is just one option. So I go to bar plot and do with summary. The categories are in the variable 3 position, and the counts are in the variable 4, or the frequency, right? This is the frequency. We want order by value ascending, which means just keep it by the order that we have it. Value above the bar, and then go down and click compute. Here's our chart. It's our bar plot. Not technically a histogram because there should be no gap in here, but for us, if we're doing homework problems, basically we're smashing them together and then it's a histogram. So this works just fine. Same thing here, and that's how you use the bar plot to create a bar plot. The last thing here is assessing normal distributions with a normal quantile plot. This is something we'll use later in StatCrunch, but right now they want us give you another look at what could be normal. So not a normal distribution. The population distribution is not normal if the normal quantile plot has either or both of these conditions. The points do not lie reasonably close to a straight line pattern. So they have to be close to some straight line pattern. The points show some systematic pattern that is not straight line. Okay? So in the first one here, these dots lie reasonably close to making a straight line pattern. They're around the straight line and they're up and to the right. Notice they're following that green line. Here, the dots do not follow the line at all, and they make some kind of curve like that. They just start low, go up really fast, and then go straight across and not following that at all. Here, they seem to follow the green line, but look at what they do. It's a very systematic pattern, right? You can just follow and predict where the next one is. Whereas here, you couldn't predict where the next one would be. So this would be a normal distribution. This data has been calculated and plotted against this straight line. And then it says, yes, it's a normal distribution approximately. And these two are not normal distributions. So this is taken something that might look like this right here and plotted, and it shows this right here. Okay, that's basically the short notes of 2.2. You'd probably want to check out the book to get more in detail of more of the information, but hopefully this gets you through the homework. Put your questions in discussion, please.